Hello students, in this particular video, we'll see what is spectroscopy. Being a science student, you must have heard about this word many a times. So let us try to find out what actually it is. Spectroscopy is the study of interaction between matter and electromagnetic radiation. It is used to identify, quantify, and analyze the chemical substances. Different molecules absorb or emit specific wavelength of light, creating unique spectra. It's just like a chemical fingerprint. There are different types of spectroscopic techniques. The first one we can consider is UV visible spectroscopy. Principle here is it measures absorption of UV visible light by molecules. Applications: it's applicable for quantitative analysis of compounds like drug concentration in pharmaceuticals, study of conjugated systems as in dyes or organic molecules, and even kinetics of reactions can be monitored with reference to absorbance over time. Next one is infrared spectroscopy. It measures vibrational transitions in molecules using infrared radiations. Applications are functional group identification can be done, as in alcohols, carbonyls, aldehydes, etc., can be studied with the help of this technique. It helps for characterizing polymers, as in plastic quality control, and even environmental analysis. It's highly applicable, as in detecting pollutants within air or water. The next spectroscopic technique could be considered nuclear magnetic resonance spectroscopy. It measures nuclear spin transitions in a magnetic field. It's applied for structure elucidation of organic molecules like proteins and drugs. It's also used for study of molecular dynamics and interactions and metabolite profiling in biological samples. Mass spectrometry or mass spectroscopy is one of the important technique for molecular weight determination, identification of unknown compounds, highly applicable in forensic analysis studies, proteomics and metapolomics, that is study of proteins and metabolites. The principle involved within this technique is it ionizes molecules and separates them based on mass to charge ratio. The next technique is Raman spectroscopy technique. Principle here is it measures inelastic scattering of light, also termed as Raman effect. Applications are non-destructive analysis of materials can be done with it, like art restoration, or crystal structures and polymorphs can be effectively studied. It is also helpful for detection of explosives and hazardous materials. Next one is X-ray spectroscopy. Principle involved within this technique is it measures X-ray absorption or emission by atoms. Applicable for elemental analysis like metals and alloys can effectively be analyzed with the help of this technique. Applicable in crystallography, that is determining 3D structures of molecules, and in material science as well, like semiconductor analysis. As far as the real world applications are concerned, it's highly or widely used within pharmaceuticals for drug development, quality control, and impurity analysis. Within environmental science, spectroscopic applications are with reference to detection of pollutants, water quality monitoring. In forensics, it is used for identifying unknown substances at crime scenes. With reference to material science, it is used to analyze polymers, nanomaterials, and catalysts. Biochemistry, it's used for studying biomolecules like proteins, DNA, and enzymes. There are different challenges associated within this spectroscopy. Say, complex data interpretation is difficult since spectroscopy techniques provide you with certain spectra and it is very difficult to analyze it unless and until there is an expertise within the technique. As far as the sample preparation is concerned, some techniques need very pure, well prepared samples, and we need maybe possibly some dilute or concentrated samples depending on the techniques applied. As far as the cost is concerned, advanced instruments like NMR and mass spectrometric techniques are expensive. Finally, we can conclude spectroscopy is a powerful tool in chemistry with applications spanning pharmaceuticals, environmental science, forensics, and many more. Mastering spectroscopic technique is really essential for modern chemists to solve the real world problems. Thank you.